So we are doing scientific notation division. Today, it's going to be a little bit backwards. I do not want any exponents in the denominator. Okay? So, with that being said, just like we've been multiplication, or when we've been multiplying, have I been able to see times 10 to like the negative 4? That very first example in the warm-up, did we have it times 10 to the negative 4? This is where you say yes or no. So if you're looking at your warm-up, we just did a problem. Did our answer say times 10 to the negative 4?
Yes.
Yes, okay. So when we're doing scientific notation, the exponent can be negative. Okay? That's key today. If I had a number, it doesn't matter what the number is, times 10 to the negative 2, could I bring this times 10 to the negative 2 to the numerator? How? Isabella? Yeah, so the whole thing would come up and the negative 2 would become positive. Everybody with me there? Okay. Everything needs to be in the numerator. So what happens though if we had something that looked like this? And there was a times 10 to the positive fifth in the denominator. David, what do you think?
When it goes to the numerator, wouldn't it just be negative?
Beautiful. If it's positive in the denominator and we use that reciprocal, it comes to the numerator and becomes the opposite. If it's positive, it becomes negative. Everybody with me there? We cannot, listen again, we cannot have our base and exponent in the denominator. Everything needs to be in the numerator. Everybody with me? Okay. I promise today's lesson isn't long. It's a lot of practice. Division. Step 1. Divide the, I started to write the wrong word, coefficients. So we are dividing the coefficients. And then I'm going to have you formulate the second step. Because remember, for multiplication, we multiplied the coefficients, kept the base of 10, added the exponents. Today, you're going to figure out what we need to do with the exponents. So, let's start off with a nice, easy example. 4 times 10 to the 4th divided by 2 times 10 to the 3rd. This is a division problem. Scientific notation in the numerator, scientific notation in the denominator. It's one of those days I'm going to stutter a lot. I didn't sleep well, so I'm going to start stuttering. That's what happens when you box for so many years. Yeah, you're laughing. Not really a funny thing. Kind of a worrying thing. So, what do we need to do first? What am I going to divide first, Jackson?
The 4 and the 2.
Good, the 4 and the 2, because these, right here, are what? What do we call these numbers here? The coefficient. Very good. Now, please understand this. When we divide scientific notation, our number will always be, for what we're doing, in the numerator. So there will no longer be a fraction bar. So we've now got 2. If I just gave you 10 to the 4th divided by 10 to the 3rd, what would we do normally? If I just gave you this, what would we do?
Wouldn't we add the base, not the exponents?
Not add. You're close. Megan? Oh, we would subtract the base. Or we keep the base, we subtract the exponents. Okay? So 10 to the 4th divided by 10 to the 3rd. 10 divided by 10 is going to divide out. 10 divided by 10 is going to divide out. 10 divided by 10 is going to divide out. That leaves me with 110. So we're always going to keep that base of times 10. But in this case, 4 minus 3 is 1. That's my answer. That's it. We're done. Yes, ma'am.
But what about that stuff you did over there?
I understand. Remember I said, hey, we're going to figure out this rule? All I'm giving you is the basics. We're going to do this. Okay? Because does my answer have a exponent in the denominator?
No.
That's the only key. We don't want our answer to have an exponent in the denominator. So let's do this one. 6 divided by 2, let's go times 10 to the negative third times 10 to the negative 9th. Now there are two ways to do this. We could take our denominator and move it up to the numerator. But you have calculators, correct? Okay? Can we do 6 divided by 2? Is that the easy part? We should be able to do that in our head, yes? So 6 divided by 2, Carly, what is that? How many times does 2 go into 6? 3 times. Times 10. We're going to always keep the base. Now, I think it was Megan who said, or maybe it was Isabella, we subtracted our exponents. Because it's division. That's what we've been doing. Can we subtract our exponents? Absolutely. Get your calculator. So this takes a little bit more work with the calculator. So we're not subtracting the tens, we're just subtracting the exponents. So let's go. Negative 3. With the negative, it's the one in the parentheses again. So I'm going to get this real close. So we're going to go negative 3. Then we're subtracting, so minus a negative 9. And press enter. So you should see a negative 3, a minus sign, then a negative 9. What does that give me? 6. There's my answer and I'm done. Isabella.
Would you not be able to do negative 9 times negative 3?
It has to be the numerator subtracting from the denominator. Okay? Now, yes, Jackson.
Since I want to do things in my head, would it, could you just subtract the 3 from the 9 and then take away both the negative signs?
Not always. So, may I show you a different way of how we could do this? Okay? So some of you are looking and saying there's a lot of negatives. What did we do over here? We moved our denominator's exponent where? To the numerator. So this problem could still be 6 divided by 2 times 10 to the negative third. What would happen to this in 10 to the negative 9? Where would it go? And become?
Positive.
Oh. So I can still do 6 divided by 2, which gives me 3. Then I'm adding negative 3 and negative 9. And if you need to have a number line, hey, go for it. Here's 0. Negative 3, negative 2, negative 1. 1, 2, 3, 4, 5, 6, 7, 8. So we're starting off at negative 3. And then we're adding 9 to it, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. That's how we're ending up at 6. Everybody with me there?
Mr. A,
Yes, ma'am.
correct me if I'm wrong, but this looks like what we applied kind of when we had negative exponents.
It's
or not?
absolutely what we were doing with negative exponents. Yep. Absolutely.
So it's the same idea.
It's the same rules the entire time through. So, division. Divide the coefficients. Subtract. What? What are we going to subtract? I told you to get the rule. Evans. Okay, which exponent first?
Numerator.
Good. Subtract. The exponent. Good use of mathematical language. The exponent in the numerator. Bless you. From the exponent in the what? Denominator. Very good. Again, mathematical language. Love it. Okay? And you've got calculators. Your calculators are going to be your lifeline right now. And why do I stress calculators more than a lot of teachers? because I'm teaching the long game. In the real world, there's very few times that you are not going to have your phone, a calculator, a computer, where you're going to be able to do this. Do I wish that at this point you knew how to do this math in your head? Absolutely. But that's why you had 6th, 5th, 4th, 3rd grade to do adding and subtracting. Now, I'm trying to teach you bigger concepts that I want you to know the concepts. I don't need you to know, I need you to know how to use a calculator. Okay? So, you're going to try 2 problems. Okay? Pretty easy. Divide the coefficients, subtract the exponent in the numerator from the exponent in the denominator. I'm going to put one little caveat here. Exponent and base will always be where? Where does that exponent and the base always have to end up once we divide? Come on, I need hands. Come on, I need some hands. I need some hands. I need more hands. Come on, I've seen these hands already. Come on, Brooklyn, where does it have to be? Numerator or denominator? What do you think? Good. The exponent and base will always be in the numerator. Okay, so let's try these 2. Let's go. 9 times 10 to the 4th divided by 2 times 10 to the negative 3. And example 2 will be 8 divided by 4 times 10 to the negative 7 times 10 to the 3rd. So a little bit different, a little bit tricky, nothing overly hard. Use your calculators. Give it a try. I'm interested to see how you do with the first example. So we're dividing the coefficients, and then we are going to subtract the exponents. You can use your calculator to do the division too. Not that I don't want to use your calculator, I should use mine.
Is that what you said? I didn't hear you. I thought you just said 4. Okay.
Yes, ma'am. Can you catch?
How are you going to figure out?
Good catch. We were incorporating PE into math, right?
Any subject from PE is your grade of a 9.
That's right. Can I brag on one of my other classes?
Sure.
I got my first gift of the year. Boom.
Great, now we're gonna have this all for Christmas.
Oh no.
Going forward.
I'll show you on Friday. We'll never be able to top one of my things. Okay, so listen. I just want to do the first one. Just want to do the first one. Grego.
Yeah.
Did you do 9 divided by 2 in your calculator?
Yeah.
Okay. What was 9 divided by 2? Speak a little bit better.
4.5.
Not clear. Can you speak more mathematically?
4 and 5 tenths.
Thank you. 4 5/10. So we divided what? What are those called? Come on, I need more hands. What were those numbers called? Bianca. These weren't the exponents,
Oh, the coefficient.
the coefficients. 4 and 5/10. Is this number in scientific notation? Is that fine?
Yes.
Yeah, that's still fine because it's at least 1, but less than 10. Okay, Maddie, what do I have to keep next?
Keep the base of 10.
Yeah, times 10. Now what do I do?
Then you subtract 4 and -3.
So,
You get 1.
no. Get your calculators. It's specific that you have to make sure that you're doing this. It's not 4 minus 3. That's not what this is saying. It's the exponent in the numerator, 4, minus the exponent in the denominator, which is -3. 4 minus a -3. Simone, what's that give me? 7. And some of you are saying, Mr. H, how is that possibly 7? Well, let's go back to exponent rules. Okay, I'm going to rewrite this differently. So I have 9 divided by 2 times 10 to the 4th. What could I do with this 10 to the -3? Can we have negatives? We can, but where could it go? And becomes?
+3.
Oh. And we know when we have like bases, we keep the base and we do what with the exponents? Add them. Which still gives me 4 and 5/10 times 10 to the 7th. Okay? Everybody with me there? I'll give you 30 more seconds. Go. Coming back, man. Yes, you do. Let's see what we can do. Yeah, it gives you a fraction. Let's see. What you want to do about these? This one. Okay, so if I'm going to do 9 divided by 2 equals 7.
See, it's not exactly that.
Okay? Yep. Yeah, 7, I think I figured out on your calculator too.
You just divide them.
Do you have an SD button?
You subtract that and use that extra.
Okay, cool.
Do this. That's how I do it.
Oh, okay. Let me change that for you. Yep. Folks, let me clarify here. I misspoke. It's not subtracting the numerator from the denominator. We're not taking 3 minus a -7. We're subtracting the exponent in the numerator and the exponent in the denominator. So it's the numerator minus the denominator. Okay? Kind of what we've been doing for all of these. So, what's 8 divided by 4, Brooklyn? Is what? 2. What are we going to do in our calculator right now? So I need somebody to speak perfectly clearly, and I know Caleb's got me. So what am I going to do with my exponents, Caleb? Okay, so let's get the calculator. You're going to walk me through this process. Okay, so you're going to tell me what buttons to press, because I know you got this. Don't worry, you're only on camera. Well, you're not on camera. So, here's my calculator. Go ahead, what am I pressing first? -7, then what? -3. That's it, press enter. That leaves me with a -10. So now that I have that base, or now that I have that exponent, we keep the base. And it always stays in the numerator, gives me a -10. Yes, ma'am.
So, when you subtract, you always do the one that is in the
Numerator, yes. Yep, numerator first, denominator second, always. Good question. How about we do some practices? Fair enough? Now I'm going to add something on it. With multiplication, you know how to multiply the coefficient, right? That was the easy part. But then we added that, what if it's like 12 times 10 to the 4th? Then you had to change it to standard form, get it back into scientific notation, and we had to go all over the place. So let's do this. So now the directions are going to be a little bit different. Let's make sure we can see over here. I don't know if we can. Move, move, move. Divide and keep in scientific notation. So we're going to do 3 problems. Number 1, let's go. 3 2/10 times 10 to the 8th divided by 1 6/10 times 10 to the 3rd. Number 2, 5/10 times 10 to the 9th divided by 1 5/10 times 10 to the -7th. And number 3, because this one's going to be, I'm going to put a star here. Let's go 12 times 10 to the 4th divided by 16 times 10 to the -5th. Give them a try.
This is our homework.
No, this is practice problems right now. And I might change number 3 here in a second. You can round number 2 to the nearest 100. You can round number 2 to the nearest 100. You're a little confused, that's all right. That's why we're practicing. Use your calculator. That's why you got it. Let's go with about 1 more minute. I want you to know something like number 2, but you will not see questions like that on your test. So that's going to change things. Okay, once you have that decimal, then you need to say, that inside notation. Okay? We're good.
Number 2, we round to the nearest.
Round to the nearest 100th for number 2. Let's get from 9 minus.
Then they're giving the answer.
And then would you subtract 1?
Very good, guys. That is,
I just thought of
ladies and gentlemen, I'm going to come back to you, that group right there. That was fantastic. That was absolutely fantastic what they just said. Listen, we're going to have bunches of practice problems. Please make sure that you at least give them your effort. Try these. You're going to have 4 more practice problems to try before we leave here. Okay, so, listen, this is important for me. I need you to please, please, please write these down. If you missed them, write them down. I'm going to call on you whether you have it right or not. So be ready to answer some questions. So Mason, in number 1, what do I start doing first?
You divide 3.2.
Can you say that more mathematically? 3 and 2 what?
2 tenths.
Good. Divide that by
1.6 tenths.
1 and
And 6 tenths.
good. What's that give me?
2.
2. Okay. So let's stop there. Let's not think any more besides that. This is 2. Is this fine for scientific notation? Is my coefficient of 2 fine for scientific notation? Thumbs up, thumbs down. Yeah, thumbs up, because it's at least 1 less than 10. Times 10 to the. Okay. Who haven't I heard from? Michaela. What do I do with my exponents?
You subtract 1.
Okay. What's 8 minus 3?
5.
Oh. Alyssa, do you agree with this? That one is an easy one. You will see this more so than 2 or 3 on your test. But I need you to know these because I'm a stickler for actually knowing how to do the math. And again, I wanted to see which group could come up with it without me prompting them. Holy moly. Next. Okay. Let's see. Simone, what do I need to do first?
Divide.
Okay, what am I going to divide?
1.5.
Wow. Say this better. How do we say this more mathematically? 5 what?
5 tenths.
Divided by?
And 1 and 5 tenths.
Very good. 5 tenths divided by 1 and 5 tenths. Now stop right there, just watch. Your calculator should give you, and it's going to keep on going. 3. This is called a repeating decimal. Okay? I asked you to round it to the nearest hundredth. Tenths, hundredths. So this is the decimal that I want to stop at. So which decimal do we look at? We look at that 3rd place. If it's less than 5, we keep it where it is, which it was. So it's going to stay as 33 hundredths. Everybody with me there? Who got 33 hundredths? Okay, that's good. Times 10. Whew. Jackson, what do I do next?
I was going to
Go ahead.
say, what if we put 3 bar?
Hmm?
What if we put 3 bar?
That's not rounding to the nearest hundredth. That means that it's going to keep on going forever. So if I ask to round, you need to cut it off. That's a good question, though. Yes, ma'am.
Okay, so if you have an ongoing number, don't you have to put the line over the last number?
So if I didn't want it to be rounded, and I wanted to put this repetan symbol over it, that would mean that it's repeating forever and ever and ever, which isn't rounding to the nearest hundredth. Because we rounded, we want it to stop, which is why we don't have the bar over it.
Okay.
Good question. Okay, does everybody understand that? Okay, now with my calculator, what am I going to do, Swill? What am I going to do with my exponents?
You're going to subtract, or
Tell me exactly what I would put in my calculator. So grab your calculator if you need to, and tell me exactly what buttons I'm pressing.
you're going to take 9
Uh-huh.
minus
Go ahead.
-7.
Good. 9 minus a negative 7. Make sure you use that negative, which gives me a positive 16. Now, I'm going to tell you that you should probably write it in standard form first. This group figured it out. Have we ever seen the decimal in front of our number, though?
No.
No. We've always had it behind that number.
Yeah.
So let's see what happens here. So here's the decimal 3, 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Where does my decimal need to go? Go ahead, Isabel. Between the two threes. It needs to be 3 and 3/10. Okay, I don't care which three of you said this. You said, Mr. H, what did you tell me? Go ahead, Haley.
That if, well, we were doing number 3.
Yeah, we were
But
doing
if
number 3.
Okay, that's
if
fine.
there's a decimal in front of the numbers, you move it to the right and then subtract 1 from the exponent.
That's wonderful. Because the decimal was in front of the number and not behind it, you did what? Tell me one more time. You did what to the number?
Subtract it.
You subtracted 1 because we're moving this one place over. So how many are left? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Show of hands. And I don't expect a lot. Show of hands. You got this one right. More than I thought I would. Guys, that's wonderful. Okay? Still write it out in standard form if you need to. Let's see. Number 3. So we're going to divide the coefficients. I need some help. I'm not that smart. B, what's 12 divided by 16?
12 divided by 16 is 0.75.
0.75. No.
I tried.
It's the right numbers. Speak math to me, brother.
Okay.
Okay.
0 is 7,500.
Very good. 0 and 7/75 times 10 to the 4 minus a negative 5. Minus a negative becomes positive. Going to give me positive 9. They told me already that if I'm moving it to the right, which we have to because it needs to be 7 and 5/10, we're going to subtract a decimal or subtract an exponent. But let's make sure. So that's 1. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. You said 7 and 5/10. So now the decimals there. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. 9 minus 1 gives me 8. Questions? Again, you probably won't have questions like this on your test. I'm telling you that right now. You probably won't. Okay, we got 4 more problems.